All right, first thing we're going to do is we're going to talk about what is called an irrational number. Okay. All right, irrational numbers are numbers that can't be written as a fraction. Okay. We're talking about non-repeating, non-terminating decimals as well. All right. But for the purposes of our class, we're going to be talking about stuff like the square root of 5. Okay? This is an example of an irrational number in this section of radicals. All right? Anytime that you have basically the square root of a prime number, then it's going to end up being an irrational number. Okay? That's what we're talking about today. All right? That's pretty much all there is to this one. All right, so let me show you some examples. What we're going to do, let's do some directions first. We're going to simplify the radical. Okay. Now, the reason we brought up the definition of an irrational number is because in this section, we're going to end up with leftover stuff underneath the radical. Before, we had stuff that popped out perfectly when we took them out in groups, right? So it was lovely, the radical went away. Now the radical more than likely will not go away anymore. It'll be stuck too, okay, to anything that you took out. So let's simplify a radical and I'll show you what we're doing. Like the square root of 72, okay? Now, one more time, why is this the square root and not a cube root? What's my index?
It's a 2, it's always supposed to be.
It's always 2, right? No index shown, right? There's no number here. That should be a 2. It is a 2, okay? If you want a 2 to show, you can do that. Now, if you want to, you can break 72 down into some numbers that you know and love that multiply to give you 72, such as 9 and 8. Does everybody agree with that? Mm-hmm. We got that, okay? Do you want to break it down more, or do you want to take stuff out now? That's completely up to you. What would you like to do?
Break it down more.
Break it down more? I'm going to not break down the 9, but what I will do is break down the 8. Is everybody cool with that? Mm-hmm. Right? So 8 is 4 times 2. Again, I'm putting a larger dot so you can see the difference between the 9 and the 8. All right. So there are 2 numbers in here that we know the square root of, right? What's the square root of 9? 3. Now remember, since they're multiplying inside, it'll be multiplying outside. What is the square root of 4? 2. So you've got the 3 from the 9 and the 2 from the 4. Notice we have a leftover 2, right, that we did not use. And that's okay. With leftovers, that's fine. We like those. Those are yummy. All right. 3 times 2 is 6. So this is just 6 root 2. That's it. You cannot go any further with this problem. If you got leftovers, you don't have another 2 in there to pop out to come out cleanly. Does that make sense?
Yes.
Yeah? Okay. Let's do another example. Let's try the square root of, let's do 75. Why not? Let's keep it in the 70s. Not a great era, but that's all right. Just my opinion.
I wasn't there during that time.
All right, 75. Break it down for me. What times what is 75?
25 times 5.
25 times
3, sorry.
25 times 3. All right. I think we're pretty much good to go there. What's the square root of 25? 5. All right, so that guy goes there. Does 3 have another pair? No. It's stuck underneath the radical, and it's going to stay there. That's it. Notice that the 3 is prime. Yes? Notice in the previous example, the 2 was prime, right? Unless they have another pair, they're stuck. Okay, always a bridesmaid, never a bride. Let's try the square root of 99. Let's do a little easy.
before we start hitting the
That is not pretty. 33 times 2.
99 is, there's 11 times 9. I'm good with that. Okay? Yes, ma'am.
So generally, we would have to pick something that would have a square fully.
That's where I'm going with this, yes. Yes, you're noticing the same thing, right? Yeah. And again, 99, don't think about it too hard. Just go straight for what you go for right away. It's got a 9 in it. Got an 11.
I went for 33 times 3.
That's what I did.
Okay, I'll do that one right after this one. How's that? So what's the square root of 9?
3.
So this is 3 root 11, right? If we do it the same way, but differently. You said 33 times 3, right? There's nothing wrong with that. Break the 33 down though. What's 33?
Yeah, okay.
3 times 11, right?
Yes.
Times 3. Okay, I'll put this big dot so that separates the two parts. Do I have 2 3s?
Yes.
So those 2 3s pop out, leaving me with the square root of 11. I get it. The same answer, no matter how I slice it, how I does it.
Okay.
Okay? So math is perfect, wonderful. You get the same answer no matter what. Any questions so far?
No.
You betcha.
Thank you.
You're welcome. Now, let's start out with variables for a second. I have P, let's do P cubed first, okay? P cubed. Now, normally we could expand this out, right? And give me, what, the square root of P times P times P, right? Whether or not I put dots in there is obvious. It doesn't really matter. Do I have 2 of a kind in here? Yep, those pop out, giving me a P, right? That's one pair. All right, and I'm left with the square root of P. That's nice if you want to do it that way. But, okay. What if I give you the square root of, say, let's do a to the 23rd. Do you really want to write out a 23 times? Hell no, and neither do I.
You would do the index into the radical, right?
Kind of, sort of, if we're on the same path. Let me see if we're saying the same thing.
2 into 23?
Yes and no. Hang on. 2 is even, right? Everybody agrees with that. 23 is not. What number below 23, directly below 23, is divisible by 2?
22.
22. What you can do is you can rewrite this as a to the 22 times a to the 1. Do you see where I'm going with this? Now 22 is perfectly divisible by 2 now, yes? Okay. What is 22? Because of the fact that variables work differently. Take the 22 divided by your index of 2. And what would you get as far as a number?
11 times 2.
11. It would be 11, right? 22 divided by 2 is 11, right? 11 times 2 is 22, correct. So 22 divided by 2 is 11. So I would have 11 groups of A. But notice I have 1 left over.
So it just stays in the fridge. Okay.
Right? So I have the 8 of the 11 times the square root of A. How does this working? You want to try again?
Absolutely.
Okay. I'm just going to move it. Do you want another one like that, or do you want something a little different?
Different.
So again, up a little bit. Kick it up. Just a touch. All right. What if I give you the square root of 28, r to the 9, t to the, let's do 14. Why not?
Okay. Spicy.
All right, I'm only going to go this far. Okay. what is the deal with the variables, right? So let's break it down like we did before. All right, the index is 2, so that's telling you that I want a number less than 9, directly less than 9 that's divisible by 2. And what is that? 8. All right, so we have 2 times the square root of 7, r to the 8, and r to the 1. Both of those, when you add those, using exponent rules, they add to give you 9, right? Didn't change anything. What about t to the 14? Is that okay, or do I need to change it?
Yeah.
It's okay, because it's divisible by 2, right? All right. What is 8 divided by 2?
4.
4. So this is 2r to the 4th. Now my r's are done. This r cannot come out. And what is 14 divided by 2?
7.
So I have t to the 7. Again, I'm dealing with, what am I dividing by? Not the outside 2 here. The exponents deal with the index. Okay? So 8 divided by this 2 gives me 4. 14 divided by 2 gives me this 7. So I end up with the square root of 7, and what's left? R. You got leftovers? So what? It does not matter. Not everything in math is going to turn out pretty. How'd that go? Good? All right. I think you all got a little comfy. What if I gave you a higher index? What if I gave you the cube root of 24 m to the 7? Why not? Okay, so when I break these down, I'm using the index to help me break the number down. 24 does have a number that is cubed in it, and that is the number 8, right? 8 is 2 times 2 times 2, right? So I'm breaking it down in terms of a number that is cubed inside it. All right, and I broke down the 7. What number less than 7, directly less than 7 is divisible by 3? 6. So that's why I divided it that way, or split it up. What is the cube root of 8? Is 2. 6 divided by 3 is also 2. Now what do I have left over? The 8 came out. I'm just left with 3m, right? I don't need a power of 1 because it's understood that it's not there, it's a wonder.
No, I did that a long way.
And I forgot one important thing. Did you see it? And this is a very traditional mistake that a lot of students make. I forgot the index of 3. Right. Now, if you left this as your answer, I'm going to mark you a little wrong because what you just did is you changed the problem from a cube root to a square root. Does everybody understand that? All right. If it's a cubed root in the beginning, it's going to be a cubed root in the end. So please, please, please do not forget your index. If it's not 2, has to be written as part of your final answer. Okay.
So I did 8 times 3, but I got 2 times 12.
You can do that.
That's
I can do the same thing again. So if I do this same problem, right? So this is the final answer, and I'm going to show you the exact same thing. I just got to move this up. Okay. I'll write it on this side. You went and did
2 times 12.
2 times 12. What did you do with your m's?
M 6 and M.
M to the 6, M to the 1? Okay. Now, 12 is not a cube, right? But 12 can be broken down more. Okay. This is what's cool about math. I mean, there's so many ways. Break 12 down. What times what gives me 12? And don't think too much, just pick them.
2 times 6.
Okay. Still have M to the 6, M to the 1. I only have 2 2's here still, so break down your 6 even further. Go all the way. Break everything down into prime numbers if you have to. So what is 6?
2 times 2.
There you go. M to the 6, M to the 1. Do I now have 3 of a kind?
Yes.
Yep, that 2 will pop out. This 6. 6 divided by 3 is 2, so we have m squared. And we are left with 3m. I come out, and I did it again. Please don't forget your cube root. Okay. Notice that you have the same answers, right? No matter how you break it down further. If you have to, like I said, break it down into prime numbers, that's really helpful. Okay, so no matter how you slice it, like I said, how you dice it, you're gonna come up with the same answer no matter which way you decide to tear it apart, okay? You wanna try another one, y'all?
Yeah.
Yeah? Okay. I'm just gonna lift this up. What if I gave you the 4th root of 48 x to the 7? What number less than 7, below 7, is divisible by 4? 4, right? So if this is 4, then what's my leftover numbers? 4 plus what gives me 7? 3. Again, adding your exponents will give you back the original exponent. We're using the index as a hint to help us with division. If I use 6, 6 would not be divisible by 2. So as much as I say directly below, what number directly below 7? It can't necessarily be 6, but what number directly below is divisible by that index? Okay. All right. If I use 6 and 8, 6 is not a 4th power, and neither is 8. And once again, break these down into primes if you have to. 6 is what? 2 times 3. I'll put a big dot here. 8 is 2 times 2 times 2, as you saw. This is just 2 times 4. And I still have x to the 4th, x cubed. Again, at any point in time, you could have taken stuff out little by little, okay? It's kind of like cleaning your garage, little at a time, because, your arms get tired, okay? Or you can do it all in one at the very end. Totally up to you how you want to do it. Do I have 4 of a kind? Yeah, I got 4 2s, right? All right, I can take out that whole set of 2s. That's one set, right? X to the 4 divided by 4 is just x. And I am now left with the 4th root of 3 x cubed. Final answer. The 4 popped out, right? I have 4 x's, that's one group of x's. And this whole group, I have 4 2s that I circled, that's one set that I circled of 2s. All right, everybody else goes. Those who I circled and led on with the pen, go, come out. Anybody not circled, stays. How we doing? Notice something that's really important about this problem. All right, take a look. We're just going to start out with this on the x cubed. Notice that this power is less than the index, yes? That's when you know you're done. If when you keep reducing, this power on the inside on your variables is larger, you are not done yet. There's more that you can take out. Does everybody understand that? That is big. We do that everywhere, okay? No matter what class we do. All right, how are you guys doing? Are you comfy with this? We're okay? All right. Then what we're going to do, does everybody copy that? Okay. Fine with this?